This is an explanatory video for the Bachelor thesis, Event-Based Dynamic Reconfiguration of Component and Connector Architectures. Architecture description languages are used to create a model of a software system. Since software systems, such as embedded and cyber-physical systems, need to be highly reconfigurable, architecture description languages have to support the modeling of reconfigurable systems in order to meet these requirements. Therefore, this thesis introduces the embedded Monty-Arc language extension, Embedded Monty-Arc Dynamics. To support the reconfiguration of the system during runtime, an event system has been implemented. Additionally, the ports have been enhanced to not only transmit data, but also references of other ports. In order to add events to a component type definition, the keyword events can be used. In the body of the event statement, events can be defined. Each event has an event declaration and an event reaction. The event declaration can be seen in line 4 and describes under which condition the event is getting triggered. The event reaction can be seen in line 5 to 8 and describes what happens if the event is getting triggered. Possible reactions are the creation of new ports or the creation of new connectors. Due to the new port reference ports, it is even possible to create a new connection using the incoming port reference of a port reference port. Port reference ports can only transmit references of a port from a predefined port type. Therefore, port reference ports are defined as normal ports with the addition that an ampersand is added as prefix of the port type, as it is shown in line 4. In the following, a simple software architecture for a truck platoon is given. Truck platooning is a concept for safer traffic and higher productivity, in which trucks are following a leading truck autonomously. Therefore, each truck is connected with its pre- and succeeding truck, which can be seen on the slide. Since trucks may want to leave or join the platoon, the architecture has to reconfigure itself at runtime. If the driver of the truck wants to leave the platoon, he will give the command and the reconfiguration process starts. Therefore, the incoming port leave receives a true and an event of the truck I+1 is getting triggered. Due to this event, the truck is sending the leave signal to its pre- and succeeding trucks to inform them that he wants to leave the platoon. This triggers an event in the pre- and succeeding trucks, and they are sending their port references back in order to connect each other. The truck which wants to leave the platoon receives the references and passes them on. Now, an event is getting triggered in the pre- and succeeding truck, which creates a new port and connects the new port with the port reference they received. Since the pre- and succeeding trucks are connected, the reconfiguration process is completed. The other truck can now leave the platoon.